Bismillahirrahmanirrahim.
Miss,
Yes. Yes.
Miss, isn't this class for grade 9?
Well, grade 9 students, I mean, if you want to attend, you can. But, you know, yeah, it is helpful. It is definitely helpful all the way till grade 10. This is IGC. I'm doing past paper questions. But the thing is that if you want to focus yourself on exam only, so I don't think this topic is included for grade 9, this midterm exam. Okay, but you are most welcome. You can stay if you want. This will be helpful. But yes, this is not a topic that is going to be covered in a grade 9. Okay, question number 1. Which property of an ester, okay, which property of an ester can be used to check its purity before use as a food flavoring? Now, don't be scared of this word ester. Ester is just a liquid, whatever liquid it is, okay? What they're asking is that what is the best method of checking its purity? So which property is the most useful in checking the purity of any substance? So they have, you know, they have come up with this question where ester is being used as a food flavoring. So of course you don't want any food flavor to be impure, right? You want it to be pure. So what property will help us in yes. Okay, Javeria.
Solubility in water.
Solubility in water. See, a thing which is soluble in water doesn't mean that it's going to be pure. If a thing is soluble in water or if it is insoluble in water, how does that represent its purity? Yes, Hania? Hania? Yes?
Yes, teacher, I think the answer to this question would be color.
Why? How? Yes, Javeria?
I think the answer is boiling point, because if it was contaminated, the boiling point would change.
Very good, yes. You know, like you have 4 options and, you know, after getting 3 wrong. But yes, your reasoning is very good. See, remember we did the cooling curves and the heating curves, and remember this graph. So if this was flat, this was, for example, if this is solid and then this is liquid, remember melting would take place at one particular point and then boiling would take place at one particular point, if you remember this graph. So this was one of the ways of finding out if something is pure or not, because if there are impurities in that substance, those impurity will have their own boiling point, and so the whole mixture, whole solution will boil or melt at a range of temperatures. You know, if you have a purity, if you have impurity, okay, you know what the graph would look like? Let me use a marker. Do you want to draw with impurities? Okay. Okay, draw, but please draw correctly, okay? Yes. Can I draw a pencil? बेटा जल्दी जल्दी करो ना, मैं marker से करूँ. शाबाश.
So it will go this way, but it will keep it well flattened, but not too much.
Okay, draw. Very good. Yes, and
then
yes. Yeah, okay. This, yeah, okay. This is fine, but this you got too steep. Okay, it should have been this way, you know, just a slightly. So you can see that melting is taking place over this range. This is melting. Over these temperatures, melting is taking place. So there is no one particular. For a pure substance, now compare this with a pure substance's heating curve. Exactly flat. Okay, exactly flat. I don't know if I'm making it horizontal. Yeah. So this is pure and this is impure. You can see how the melting is slightly slanted. Okay, so melting is taking place over a range of temperature. Here, boiling will take place over a range of temperature. Okay, they can even give you these sorts of graphs and will ask you which graph is of an impure substance. So you will look at these flat parts of the graph. If the flat part of the graph is slightly sloping, slanting, then you know that this is impure. Yes, Zores? Yes, Zores, you have a question?
Yes, ma'am. First, I want to know which class is this?
Okay, Zores, I have already explained this. Okay, in the middle of the class, please don't ask these questions. Okay.
And ma'am, what are we learning today?
I'm doing past papers of separation of mixtures. Okay. Question number 2. In which pair of substances is each substance a mixture? Okay.
Should I answer?
Option. Yeah, please mute yourself now.
She's thinking, he's thinking.
Oh, you want to answer?
Yes.
Okay.
Okay. In which pair of substances is each substance a mixture? A, air, water. B, lime, water and water. C, quicktime, lime, water. D, sea water and air. Ma'am, I say sea water and lime water and water.
Lime, water, and water.
The part.
Lime water is a compound? Or
No,
is
I'm saying that the if you could see
it's a lemon?
question number 2.
Lime water. Lime water.
Same in the carbon dioxide.
Oh, yes. Yes. Okay, Zore. So your option is, your final answer is
B.
B. No, beta, no. But you made a good attempt. I liked your attempt. Okay, it was a good attempt. Now let's go through the options again. Now this is clearer than this, right? Okay, let me take it back. Let me keep it back. Remove this. Can you guys read the question clearly? Yeah, this is better.
Yes, ma'am. I can read it clearly.
Okay, good. So, okay, now let's deal with each option one by one, and let's see which option is correct and which options are wrong. Now, air and water. What about air? Is air a mixture or a compound? Sabiha, is air a mixture or a compound?
Mixture.
Very good, mixture. Why did you say it's a mixture?
Because it's full of stuff that are like these and are not chemically bonded.
I cannot understand you. Yes, Abdul Wadud?
Yes, ma'am, it is a mixture because it has many gases.
Very good. Yes, it has many gases mixed, right? Like oxygen, nitrogen, carbon dioxide, water vapors. Okay. What about water?
Ma'am, it's a compound.
Very good. That's a compound. So first option is wrong because what they are asking is in which pair of substances is each substance a mixture. So water is a compound. So A is wrong. Okay. What is lime water?
Ma'am, it's a compound.
Okay. Do you know what compound it is?
No, ma'am.
I think it's calcium hydroxide. It is calcium hydroxide. Okay, so this is a compound. Okay, now what is quicklime? So that means if lime water is a compound, that means option B is also wrong. Lime water is a compound and water is also a compound. So none of them is a mixture. Now what about C? Quicklime and lime water. So lime water, we have already decided that it's a compound. So even if you don't know what quicklime is, you know that this option cannot be the one because it already has a compound. Quicklime is calcium oxide. Okay, quicklime is calcium oxide. Okay, so again, both of them are compounds, lime water as well as quicklime. So option C is also gone. Now
Option D is the answer.
Yeah, option D is sea water and air. Why? Because air is a mixture and sea water is also a mixture. It is a mixture of,
Salt and water.
right, and many other different types of salts. Okay, let's move on to this. At which temperature does a concentrated
I
aqueous...
cannot see the screen clear.
Okay,
It's so bright.
it is very bright. Okay, इसे ऐसे करो, इसकी करो, video settings में जाओ. हाँ, ये इसको, हाँ, ये करो, हाँ, नीचे करो, और, हाँ, that's it. Yes. Okay. At which temperature does a concentrated aqueous solution of sodium chloride begin to boil? Javeria, you wanna do this? At which temperature does a concentrated aqueous solution of sodium chloride begin to boil? Okay, Zores.
Sorry, ma'am. I accidentally left my hand.
Okay, please
out of
lower your
the
hand.
room.
Okay, lower your hand, Abdul Wadud.
Yes, ma'am.
Yes.
Ma'am, I think 100.
Why?
No, ma'am. Sorry, it's 104, D option.
Why?
Ma'am, because sodium chloride is salt, and it is aqueous, so it will need a little bit more temperature to boil.
No, but why?
Because
Ma'am,
Yeah,
because
okay. Yes, Abdul Wadud, yes.
because it is in water form.
You tell Sandus.
because impurities increase the boiling point of the substance, so we know that it's not 96 nor 90. 100 is the boiling point for the
Pure water.
so it's definitely 104.
Yeah, because pure water has a boiling point of 100 degrees Celsius. So if we have added salt as an impurity, the boiling point of the solution should rise. Because remember, impurities make boiling and freezing harder. Remember it this way. Boiling and freezing both are harder. Therefore, the boiling point will increase and the freezing point will decrease. So you have to cool more to freeze, and you have to boil more to boil. I mean, you have to have a higher temperature for boiling. Okay, so it's 104. Okay, did everybody understand? Or does anybody want me to explain this? Why does impurity, why is it that the option D is the correct one? Everybody is clear about it?
Yes, ma'am.
No, ma'am, I'm not clear about it.
Okay. So Zores, I think you have not attended those classes in which I discussed the effects of impurity on the boiling of a substance. Were you there?
No, ma'am.
See, if this is a liquid, I'm real quick, I'm giving you a recap. For example, this is pure water, let's suppose. Okay, boiling takes place throughout, but for the molecules to get out and to get converted from liquid to gas state, they have to exit, right? They have to exit. Now if there are impurities sitting in the way, now this is not the exact reason, there are many other factors which might be involved in raising the boiling point, but this is one of the factors. If for example this is pure water molecules and these are impurities. Now these impurities are sitting as hurdles in the way of these molecules that want to exit. Okay, so they have to have more energy in order to be able to leave and for the whole thing to boil. Okay, or you can look at it this way, that the impurities also have their own boiling point. Okay, but whether their boiling point is higher or lower than the actual solvent, the boiling point of the whole solution will be higher than each one of them individually. Okay, why? Because these impurities are obstacles. They are hindrance in the way of the molecules which are trying to escape as gas, and so you have to supply more energy for this liquid to boil. Okay, and that is why the boiling point increases. Okay, So because the boiling point of pure water is 100, when you add salt into it, it's not going to decrease, but it's going to increase. So D is the only option which is greater than 100. Did you understand now?
Yes, ma'am.
Okay, good. Okay, now this one has chromatography, so only for grade 8 and maybe 9 students. Question number 4. Which of the following is the best method of obtaining pure water from ink? But, well, by the way, even grade 6 students can do this. Okay, which of the following is the best method of obtaining pure water from ink? Chromatography, distillation, and the other options are filtration and freezing. So एक मिनट इधर ही लिख देती हूँ ना तीनों चारों इधर दे दो. C is filtration. Okay, C is filtration. Okay, Abdul Wadud. C is filtration and D is freezing.
Yes, ma'am. Ma'am, it's chromatography.
Why? What made you say that?
Ma'am, because the mixture of ink and water, it is soluble. So, I mean miscible. So the chromatography can only separate this.
No, beta. D कैसे हो गया? Yes, Zoris, you want to say something?
Yes, ma'am. I wanted to say it is chromatography because distillation is for elements, or we could say objects that are solid more than liquid. This chromatography, it is for liquid. For example, if you put salt into water, for most of them will be used for filtration and distillation. When I was learning chemistry,
Okay,
they
okay. Wait, you said distillation is for objects that are.
Ma'am,
no,
ma'am,
I'm saying this distillation is for solids.
ma'am,
Yes, yes,
That's
Abdul
like
Wadud.
ma'am.
out of the
Sorry, I was wrong. We have to use distillation.
Very good, very good. I'm glad that you realized your mistake. Okay, good. So why? Now explain.
Because we can use the boiling point factor to separate both water and ink, and distillation is only used in liquids.
Okay. See, distillation is for two liquids, separating two liquids that dissolve with each other, miscible or which are soluble in each other, right? Chromatography is used to separate for the purpose of identification. Remember, chromatography is for identification. And also pay attention to the wording of the question. Which of the following is the best method of obtaining pure water from ink? Like chromatography might separate for you, but you can only use it to identify. Now you will only be able to identify, okay, these substances are present in this ink, but you cannot obtain pure water using chromatography. Okay, for obtaining pure water, you can only have distillation. And since ink is a solution, have you seen ink? You know, the ink that we use, it is solution. The blue thing gets dissolved. It gives it a blue color, but it is soluble. I mean, you cannot see any solid particles suspended in it. Okay, so it is definitely, both of them are soluble in each other. So we will use the process of distillation if we want to obtain pure water. Filtration and freezing are obviously very obvious wrong options. Okay, question number 5. What is the most suitable way of investigating the different food colorings in some drinks? Yes, now remember, now here they want to investigate the different food colorings. Like they don't want to separate, or they don't want to collect anything. Okay, they only want to identify. For identification purposes, it is chromatography. Okay, for identification purposes, it is always chromatography. So whenever the question asks you to identify and you know that the substances are going to be colored and you need to identify, and also their amount is less. You know, we use very small amounts of food colorings, very negligible amounts of food colorings, like they are not enough to be separated in beakers. They're not enough, the quantity is not that much. Okay, then we go for chromatography. So remember, for chromatography there are three prerequisites. For identification purposes, secondly, mostly they are colored, not always but mostly. Third, that they are in very small amounts, very small amounts. Okay. Question number 6. Which method is used to obtain pure water from a sugar solution? Now again, obtain pure water.
Ma'am, I didn't understand the question number 5.
Beta, you haven't done chromatography, have you?
No.
Yeah, so this has to do with chromatography. Okay.
You said chromatography is for identification, but here it is saying paper chromatography. So is there
Same thing.
any?
Beta, same thing, beta, same thing. Chromatography, paper chromatography, same thing.
Okay.
Yeah, but you have to know the details. Okay, you won't be able to understand this question otherwise. So I would recommend that you watch the chromatography video. Okay, now let's do this question number 6. Which method is used to obtain pure water from a sugar solution? Okay, so we want to obtain pure water, so it definitely cannot be chromatography. Now, crystallization.
Yes, I said B.
But beta, crystallization is to get crystals. Yeah. Yeah, crystallization will get the sugar out and will let the water be lost. The water will be lost in crystallization, but we want to obtain pure water. So that makes crystallization wrong. And so distillation, yes.
Filtration, the sugar, the solutions of this.
Yeah, filtration we cannot use because sugar is soluble. So it will flow along with the pure water through the filter paper. So yeah, so we cannot use filtration for the sugar solution. So distillation is what we can use to obtain pure water. Okay. Then question number 7. Which substance could not sublime when heated from room temperature in the laboratory?
A solid carbon. Yes.
Yes, Abdul Wadud is the only one
Iodine.
raising hand. Yes, Javeria. Which substance could not sublime when heated from room temperature in the laboratory?
Is it iodine?
Same when I was saying iodine.
When heated from room temperature. No, beta, not iodine. Yeah, you have to, in this, you have to know the substances which sublime. Do you know the substances that sublime?
Yes, I know.
Okay, Sidra, tell.
Iodine, carbon dioxide.
Solid, yeah, okay, solid carbon dioxide. And ammonium chloride. These three sublime. Okay, you have to learn this. These substances, maybe there are other substances that sublime, but for your level, just these three substances. Okay, learn these three are the ones that sublime. So mercury is the only one.
And even if you don't know which substance is sublime, you do know that sublimation is like a direct transition from solid to gas. So mercury is in liquid. That's not going to sublime.
Mercury is a metal. If you remember, yeah.
So, and it's also a liquid metal, so it cannot sublime. So
yes, very good, Sundar. Yes. So these are covalent simple molecules. These are covalent simple molecules, and this is metal. So we can see that, and metals exist as solids at room temperature, and they are very hard solids. So we don't expect them to sublime. Sublimation is direct change of a state from solid to gas without passing through the liquid phase. Okay, so not all substances undergo that, only these three as far as I know. And so mercury is a metal. Okay. Okay, question number 8. Let me hide this. What is necessary for two substances to be separated by paper chromatography? Now again, this is chromatography. What is necessary for two substances to be separated by paper chromatography? That they are both liquids, they are both soluble in the same solvent, they have different densities, they have different colors. Abdul Wadud?
Ma'am, they have different colors.
Okay, Abdul Wadud, are you in grade 8 or grade 9?
8, grade 8.
Okay, is this topic is included, right, for your midterm exams?
Yes, ma'am.
Okay. Okay. So,
Why are you not asking me?
Zores, please mute yourself. Okay, so no, beta, even if the substances are not colored, remember in your book they have locating agents. Do you remember? In your book, they have mentioned locating agents which are used for colored substances. So even if they are not colored, we can still carry out paper chromatography. So that is not important.
Ma'am, it's option B. They are both soluble in the same solvent.
Okay, why?
Ma'am, we have to the solution should be in one solvent so that we can do the chromatography and identify the colors.
Right. I think you are the only grade 8, or maybe Aisha as well. Okay. So yes, so for chromatography to take place, the substance has to dissolve in the same solvent. Sorry, for chromatography, for example, this is the paper, okay, and this is the solvent. So which physical property do we make use of in chromatography? Which physical property, which
Solubility.
very good. The solubility, the difference in their solubilities in the same solvent. Okay, so the substance which is more soluble will go higher up, okay, on the paper. And the substance which is less soluble in the solvent will get stuck close to the solvent, right? Because it will, yeah, it will have more affinity for the paper as compared to the solvent, and it will get stuck onto the paper quicker. Whereas the substance which is more soluble in solvent will be able to run along the solvent a long way up. Okay, so we make use of difference in their solubility, and they are both liquids. Why is this option wrong? Is it wrong?
No.
See, sometimes we have a solution, right? Like for example, ink. So they are before dissolving, they're like powder. So we can call them like solid. And when we make a solution out of it, so that's not important. Even if you have solid, you can dissolve and you can have solution and you can carry out paper chromatography. Salt and sugar. Well, if you use locating agents for them, maybe.
Locating agent only works on protein.
Ma'am, I don't understand why is can you hold your paper down? I don't remember the option B that well. Can you put your paper down for me?
Beta, you haven't done chromatography, right?
Yeah, but I'm trying to learn it. They're both soluble in the same solvent. Why is it in not the other options like they're both liquids or they have different densities?
Beta, I appreciate the fact that you're trying to understand, but the thing is, I haven't explained. I am just discussing the question. When I explain, then then you try to understand, and then if you ask question, then I can answer. They have different densities. Densities has nothing to do here in chromatography. We don't make use of density here. Okay. Okay. Okay, but the rest of the questions will be related to you. Okay, it's only chromatography which is not included. Can I have rough papers? Okay. Okay, then let's do 2 more questions and then I want to do structured questions. Okay, these are MCQs. Now, a gas X is less dense than air and insoluble in water. Okay, less dense than air and insoluble in water. Which method cannot be used to collect the gas? Now look at this, A, B, C, and then this is D. So D is just simple gas syringe. So the gas is less dense than air. Secondly, it is insoluble in water. Aisha?
A.
Muhammad? Come on. Beta, I want new hands. Yes, Aisha, very good.
D.
D, gas syringe.
Yeah.
Okay, why? Can you explain? Less dense than air and insoluble in water.
Because it's less dense, it might escape.
Okay, and so you want to use a gas syringe, okay? And what about insoluble in water? Okay, why not? Okay, 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 Sandus wants to.
Okay, so
Okay, Sidra, okay, let's give Sidra. Okay, Javeria se bhi sun lete hain. Okay, Javeria beta.
I think the answer is C because as they mentioned, the gas is insoluble in water. So C cannot be used to collect the gas.
Beta insoluble hai na? Okay, Sidra, you want to say?
it is A, because when the gas will enter through the tube, and there's no bong or anything on
Bung.
top, bung on top of this tube. So because it is less dense than air, it will rise and the air will be collected into the beaker instead
It
of
will escape.
tube.
It will escape.
It will escape,
Okay.
and so it cannot be used to collect the gas.
Okay. Now, before you say that, also tell me why are the other options wrong? Remember,
Because-
which method cannot be used to collect the gas? So you're
because
saying
over here-
A is the answer. We should not use this method because the light gas will easily escape,
Yes.
right? Okay. What about B and C? Why are they wrong options?
Because if the air X will enter the tube, because
In B,
this,
are you
yes,
explaining
yes,
B?
yes.
Okay.
So because the tube is inverted, the obviously the X will rise,
Yes, because it's less
rise
dense than
because
air,
it's
so
less
it would
dense,
rise.
and air would be below, and so it would get collected on.
Yeah,
in
okay, so
top.
this is gonna work out. Okay.
And then why not C is because so when A,
Okay.
because so when X will when the air X will enter through the tube, because it's not soluble in water, it will rise through the water and will be collected on top of the beaker.
Very good. Yes.
And then why not D? Because obviously this is a gas syringe, it's not going to allow it to escape. It's going to be collected.
Yeah. I mean, D can be used for any gas.
Yeah.
This can be used for any gas at all.
So that's why I think
Okay.
it's A.
Did you guys understand, Aisha and Javeria? Javeria, why is C a wrong option? Did you understand?
Yes.
Why?
Well, because it's not insoluble in water, so it will, and because of displacement, it will rise to the top of the beaker.
Yeah, see, they have tricked you. Cannot be used. Okay, so this is the best way to collect this sort of gas because it will rise and it won't even dissolve in the water because it is insoluble. It won't dissolve. So we will collect it.
Actually,
And they
this
have
is the
asked us,
best way.
and they have asked us which is the method that should not be used. Okay. Okay, let's move on to the next.
I don't
question.
understand part D.
You didn't understand part?
Part D.
Okay, Sandus wants to explain. Yes. Okay.
So part D is the universal way to collect gases. Like you can collect any gas through this way because the gas syringe is airtight, so none of the gas will get out. And X, the tube X, where X is entering, is connected to where the gas supply. So that's why it's the
Yeah,
good way.
yeah.
to test.
See, Aisha, this, I mean, with this gas syringe, you can collect any gas, whether it is denser than air, less dense than air, soluble in water, or less, or it doesn't matter, because there is no water here, and so this is a, you know, this can be used for any gas. Are you clear?
Okay. Yeah.
Yeah. Okay. And are you convinced why A is the wrong method?
Yes.
Okay. Okay. Question number 10.
Ma'am, X is the starting, the X air, is it the starting of the air or the ending of the air?
X is the supply of air. This is
No,
gas
from the
X.
start or the end.
What do you mean start and end, beta?
Like, I don't understand this thing in A. The tube is having no X, and the other tube is having X. So which one is the start of which the air gets into the tube? Which one?
Okay, so the X is entering over here, and we're trying to collect X. So it's coming into this
Like this
test
is the
tube.
delivery tube. Okay. And this, whatever X, you know, they have to use just any symbol for
He's
a
saying,
gas.
so this is the starting of the tube.
Yeah.
this is
So
the
yeah.
ending.
Okay. So this is the supply end. This is the, you know, the
Connection.
the collection end. Okay.
Okay.
Okay. Question number 10. A student accidentally mixed 50 cm cube of water with 50 cm cube of oil. Which method would allow him to obtain 25 cm cube of the oil most easily?
Oh my God, D is the answer.
Okay. Stop. Yes, Abdul Wadud.
Teacher, can I
Ma'am,
tell?
it's B.
B. Evaporation.
Yes, ma'am.
Okay, Javeria.
Teacher, can I tell?
Miss, it cannot be
Yes,
A
Ahmad.
because
Yes. Yes, Ahmad.
Teacher, I'm wrong.
Oh,
Teacher,
okay,
D is
Raf.
the answer.
D.
Teacher, D is the answer.
Okay, why? Explain us.
Teacher, because in a separating funnel, if two liquids of different densities are mixed, we can drain out the high density liquid, and then the low density liquid will stay in the funnel, and we can collect the high density
Okay.
liquid.
Okay. Okay. Also, please discuss why are the other options wrong?
Teacher, because if we cannot do it with chromatography, because if there's like if we put like a paper with
Two
oil and
substances are
water,
not soluble, and solubility is must.
For chromatography.
yes.
Yeah.
And if we do the evaporation method, both liquids will like evaporate. We will not get anything.
We'll
Yeah. Again, for evaporation, also you need two soluble liquids. I mean, two soluble substances. Sorry, not liquids, not necessarily.
basically we can use evaporation, but they are saying 25 cm cube, and
Of the oil.
yeah, and no, we can still use evaporation
Yes.
because we'll get rid of water. But the thing is, they're saying 25 cm cube. So in a separating funnel, it's like the two liquids are layered on top of each other, and then we open the tap, and so we get oil out. But we will only get 25 cm cube because, you know, for the last part of the oil, we are too scared to, you know, like keep running the oil because we're scared maybe the water will also, you know, come through.
Yes. Okay. So yeah, because you know the other methods are also not allowing us to measure exactly 25 cm cube. So separating funnel, with separating funnel, we have that option. So we will have to let the mixture sit and get settled for a while so that according to their densities, they will arrange themselves, with oil sitting at the top being less dense and water will stay at the bottom because it is denser than oil. And then we can easily separate. And I think a picture is also there in your book.
Ma'am,
Yes.
why can't we use evaporation? We will like
Because there's a
we'll
layer of oil on it.
we will use will evaporate the water and we can get the oil easily.
Pay attention to the 25 cm cube of oil.
Yeah, very good. Yes, 25 cm. How will you measure exactly? And also most easily. For evaporation, you need heating. For separating funnel, you don't need anything. So there are many points that are pointing towards separating funnel. So most easily and also exact 25 cm cube. With separating funnel, you have that option of measuring how much you are tapping out.
Yes,
Teacher,
ma'am.
one
Now I
question.
understand. Yeah, now I understand.
Ma'am,
Thank
how did you know that it was a separating funnel? Because first of all, we did not do any kind of experiment which caused us to have 25 centimeters cube of oil.
Okay, sorry. Okay. Can I have that picture from the book? Yeah, separating funnel. Please take that picture out, please. Jazakallah khair. Yes, Zores, this separating funnel, yes, is not shown to in it's not there in grade 6 book. Okay, it's in grade 8 book. Okay, do you want to do more of these MCQs or should we start structured questions?
Teacher, one more thing.
Ma'am, I think I should do the questions where we know now, like grade 6 instead of grade 8, because I'm getting like bored of not answering.
Oh, you're getting bored. Okay. Okay, let's do this. I think this will be included in your okay. Okay, this is that picture. This is how a separating funnel looks like. Okay, so if you let it settle for a while, the oil will settle at the top because it's less dense than water, and the water will be at the bottom. You can turn the tap on and you can separate. And because this funnel is usually graduated, you can actually measure how much of the liquid you are tapping out. Okay, this is how a separating funnel looks like.
Ma'am, this separating funnel, does it have a pipe that is connecting to the tap?
No, beta, there's no pipe. Okay.
Then how is it
One
going
more
to be a
thing.
separating funnel?
Okay, a student set up the apparatus. This
It's
is
a tap. It like
there is already a nozzle here through which the liquid
no,
drips
he's
out.
saying how does it
We
go?
are not talking about the sink tap. We're talking about this tap.
Yeah,
right
this we are
under.
calling this the tap.
Yeah, I know. No, but
Okay.
I'm saying is the we say the container in which the water and oil is mixed. Is it connected? Is the container connected to the tap?
Yes, it is
you
connected.
can,
It's just
if
like
you
a
want.
tube, but the tap just blocks the tube and opens the tube. That's what it does.
Teacher,
Yes.
teacher, you said that we can use evaporation, but it will not give us accurate like 25 centimeter cube. Teacher, but I wanted to say that if we try to do evaporation, oil is less dense. It will form a layer over the water, so it will not let water evaporate. Like we will take ages, and the water will stay there.
Very good, Rafe. Very good. Yes, I like it. Yes, very good point. Very good point. Yes. Yes, I want you guys to think this way. I want you guys to do you know good scientists are the ones who can imagine, imagine, imagine that thing taking place in front of you. Think about all the factors, practically speaking. What will happen if you picture yourself doing it? Okay, and if possible, do it. Okay, and then see what's happening. What are the different factors which are playing their role? Okay, very good, Rafi. Okay, question number 1. A student set up the apparatus shown below. Now this has to do with nature of matter diffusion. Okay, a student set up the apparatus shown below. Okay, cotton wool soaked in concentrated hydrochloric acid on one end of the tube, cotton wool soaked in concentrated aqueous ammonia on the other end of the tube, and both the mouths of the tube are closed with bungs. Colorless fumes of hydrogen chloride are given off by the hydrochloric acid. Colorless fumes of ammonia are given off by the aqueous ammonia. Okay, can I also hide the, okay. After a few seconds, white fumes were seen at point X in the tube. Name the compound formed at point X. Yes. Aisha, Muhammad, and
Teacher,
Rafi.
ammonia hydroxide.
Sorry?
Ammonia hydroxide.
No, beta. Can you write an equation of this reaction? Can you write the equation? Can you write an equation of of the reaction between these two? Do you know the formula for hydrochloric acid? Do you know the formula for ammonia? Anybody knows the for formula for ammonia? बेटा आप लोगों की तो तैयारी नहीं है, फिर आप लोग कैसे करोगे ये एग्जाम? मुझे ये बताओ. I'm especially talking to grade 8 students. By the way, this I think
Ma'am,
is
NH3, sorry. Mic was not unmuting. NH3 is a
yes.
Yes,
formula.
I'm
Okay.
in grade 7.
Aisha, are you in grade 7?
Yeah.
Oh, okay. So, okay. So ammonia and hydrochloric acid. Can I have a pencil, something? Very good. Yes. Okay. So now can you come up with, so hydrochloric acid is this HCl, okay, aqueous, and this is ammonia. So then what will be the product?
Ammonium chloride
Very good. Simple.
and
Ammonium chloride. Okay, simple. Ammonium chloride. Okay. And this is balanced. No hydrogen. Yeah. No hydrogen. Yeah. So this will be the product. Okay. So your answer is ammonium chloride.
Why isn't it gas? It's smoke.
It's
No. Both the gases are reacting to give us solid,
yes.
but they are saying a white cloud.
So
So
how
white
you
fumes are
Okay.
seen at point.
Point X. White fumes were seen at
so white
point X.
fume means like small powder suspension.
Yes.
Okay.
Small
But it's
suspension in
soluble.
the air. Yes. Okay. So the product is also in the gaseous state, I think. Yeah, this will also be in gaseous state. All these are fumes. So all of them are in gaseous state. Yes, Rafi, you want to ask something?
yes, teacher. When hydrochloric and ammonia react, they always form solid.
You see, right now in this particular experiment, because they're making fumes react, so yeah, I think, yeah, fumes, it will be in gaseous state. But if you have solution, if you have like one liquid poured into another, then you will see white suspension, I think, like white precipitate. Yes, then you will see white precipitate. So what was the solubility of the chlorides? All chlorides are soluble, right? Except for all chlorides are you sure? Lead and silver. Except for lead and silver. All chlorides are soluble except for lead and silver. I'm not sure. Okay. Part A. After a few seconds, okay, this we have done. Use the kinetic particle theory to explain this observation. Okay, Sidra?
I have to explain the whole experiment, like how the
No, kinetic particle theory. What's happening? Yes.
So
except for lead and silver.
because evaporation can take place at any temperature, the particles, if the liquid particles, there might be vapors of these, because they said soak. That means
Yes.
it must be a liquid.
So there are fumes, okay? There are fumes. So you would say that the molecules are diffusing. Yeah, you have to talk about diffusion here. The molecules are diffusing, like hydrogen chloride fumes are diffusing from here. Hydrogen chloride fumes are diffusing this way because they are moving from the region of high concentration to a region of low concentration. Here again, the molecules of ammonia are moving from the region of high concentration to a region of low concentration.
And because ammonia is lighter than hydrochloric acid, that's why it traveled faster. And so if you can see, there's much more space here than over here.
Yes, the precipitate forms closer to hydrochloric acid, right? So kinetic particle theory, in kinetic particle theory, you will talk about random motion. So these fumes are in random motion and they are diffusing. And what were the other parts? And that they are colliding all the time in different directions.
All matter is made of very small particles.
Yes, yes. So when they ask you to, to use reference, they give reference of kinetic particle theory. Make sure you mention all those parts of kinetic particle theory. Only then you will get these marks. Okay. Okay, let's move on. Part C. The student repeated the experiment using a solution of methyl amine, the formula of which is this, in place of ammonia. The white fumes were seen at point Y in the tube rather than at point X. Explain this difference.
Ma'am, ma'am,
Because the
because of the particles.
mighty lime might
Okay,
be less
let Rafe answer. Okay, Abdul Wadud. Okay, Rafe.
The reason is because the solution of methylamine would be like less like less dense. I mean, like it would be like hydrochloric acid. It would form
It would
more.
it would be a bit heavier, more heavier than ammonia, just a bit. That's why it's still farther away from ammonia than.
Okay, can I know the molecular mass of ammonia? What is the molecular mass of ammonia? Can you please get the periodic table? Nitrogen is 14, right? 14, 15, 16, 17. So the molecular
Teacher 17.
17 is the molecular mass of ammonia. What is the molecular mass of hydrogen chloride?
So hydrogen
30, 35.5, right? Chlorine is 35.5.
36.4.
Nitrogen is 17. So
Chlorine
it can
is
enter
35.5.
Nitrogen has 17.
35.5.
How much is it? I don't know.
14. Okay, 14.
Teacher, hydrogen is 1 and chlorine is 35 already. So 35 and 1 makes 36.
Yeah, 36.5 if we take the 0.5, okay, because the average atomic mass of chlorine is 35.5. So you can see that hydrogen chloride is heavier. Can you see it's heavier? That's why the precipitate is closer to hydrogen
Man,
chloride.
you have written 36.5. Because 35.5 equals to 36, but it's fine if you have done a mistake. Everybody does mistakes.
Beta chlorine is 35.5, right? And hydrogen is 1.
Hydrogen. So, man, why were you adding that whole thing together? What are we, 37?
Molecular
them
mass.
off?
This is
Ma'am, it's total, it's 36.5. You're right.
Beta Zores, we are calculating the molecular mass, and by the way, Zores, you are in grade 6, right? This molecular mass calculation is coming in the exam.
I know.
You better prepare, okay? 35.5 is the atomic mass. Let me explain this, okay, Zores, because this is coming in your exam. Chlorine's mass is 35.5 according to the periodic table. Look at the periodic table. Where's the periodic table? Here. 35.5, okay? So I took the mass here of one atom and then I added to one hydrogen, because remember in hydrogen chloric and one molecule of hydrochloric acid, you have one atom of hydrogen and one atom of chlorine. So 35.5 plus 1 will give us 36.5. So that is the molecular mass of hydrochloric acid. Are you clear now, Zores?
Yes, ma'am.
Yes. Okay. So can you see that hydrochloric acid is so much heavier than ammonia? And because of this heaviness, because of this bulky, because of this molecule is bulkier than ammonia. So therefore it cannot travel too far, or it is slower. Okay, it is slower. Hydrogen chloride is faster. Now methylamine. Methylamine is CH3 NH2. What do you think it is? Is it, Zores, please do calculate the molecular mass for us.
Teacher, it's
Okay, ma'am.
heavier.
So, ma'am, what we will do, we will go to periodic table. First of all.
Okay. Okay. So do you have the periodic table?
I have a periodic table.
So carbon's mass is,
So carbon's mass is 12.
how many hydrogens do we have?
We have 3 hydrogens.
3 and then 4, 5. Right?
Yeah.
5. Okay.
Yeah.
So 5 into 1. Okay. And plus nitrogen is
Oh wait, I'm getting
One-
a piece. Okay, now.
1
Okay.
atom of nitrogen.
Sorry, say it again.
1 atom of nitrogen mass, please tell me from the periodic table. Hurry up.
14.
14. Okay. So now we have 12 plus 5 plus 14.
And 31. 31.
31?
Yes, ma'am.
31. Okay. 31.
Yes, 31.
Okay. Okay. So now instead of ammonia, now we have methyl amine. So can you see methyl amine is so much bulkier than ammonia? Methyl amine is so much bulkier than ammonia, but it is still less than hydrogen chloride. It is still less than hydrogen chloride. So that is why, because now this molecule is also bulkier, but the difference is not that much now. The difference is 36.5 and 31. So you can see that they both have traveled almost the same distance. This is a little more. Okay, now they have combined here. Like you can think of them as, running a race. Who will, meet? I mean, where will they meet? Closer to hydrogen chloride or closer to ammonia? Okay. Okay. Did you guys understand?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay. So this had to do with molecular mass and diffusion, this question. Okay. Now let's move on to question number 2. Bromine is a halogen. Bromine is a halogen. It has 2 naturally occurring isotopes. Define the term isotopes. We know this, right? Okay, Zores, you tell me, what are isotopes? Is this included?
Ma'am, isotopes are the atoms of the same element with the same number of protons but with different number of neutrons.
Very good. Okay, one isotope of bromine has the symbol this. State the
Yes.
number of protons, neutrons, and electrons in this isotope of bromine. So
Okay.
this is so easy. Sabiha.
Me, ma'am?
Yes, bromine. Let me write it big for you so that it's easier for you. Bromine 8135. So now tell me the number of protons, neutrons, and electrons.
Ma'am, if you find the protons, you will find the electrons.
Beta,
Protons
I
are
have asked
35.
Sabiha. Okay, now your turn is over. Please mute yourself. Mute yourself. Yes, Sabiha.
Protons are 35.
Protons are
35.
35. Please speak louder. Okay.
35 and neutrons, electrons are 35 and
Okay.
neutrons we have to do 81 minus 35 and the answer will be 46.
Yes. Okay. Okay. This part is done. Let's move on. Okay. Bromine is a liquid at room temperature. Draw a diagram to show the arrangement of the molecules in liquid bromine. How will you show the molecules of liquid bromine? So you just have to show the arrangement of atoms in liquid state. How will you show? So simple. Okay, this way. ये regular हो गया थोड़ा सा इसको random करना.
जी teacher.
Yeah, make sure that you differentiate it from solid. Okay, this way, something like this. Okay, now part 2. A small amount of liquid bromine was placed in the bottom of a sealed flask. After 30 minutes, the brown color of the bromine had spread throughout the flask. Use the kinetic particle theory to explain these observations. So this is liquid bromine here at the start, and after 30 minutes, you can see that bromine molecules are occupying the whole conical flask. Yes, Aisha, can you do this? Okay, Sabiha? Sabiha? Yes, beta. Can you do this? Can you explain these observations with the help of kinetic particle theory?
Okay. Actually, diffusion happened.
I cannot hear you.
Diffusion happened.
Okay.
The molecules of bromine, they were at one place, and then they started diffusing. They started moving from a high concentration to a low concentration until they were spread out evenly.
Okay, so yes, Aisha, would you like to add something? Yes, Aisha?
No.
Okay, so you have to mention that, because this is in gas.
Can I tell?
Yes, Abdul Wadud, yes.
Ma'am, the particles are moving all the time. So
Constant random motion.
in
You
a constant
keep them.
random motion, yes.
Right. Okay. And
So
so there
that's
will be net movement from a region of high concentration to a region of low concentration because the rest of the flask is empty. Okay. And so, yeah. And so they will keep moving until the concentration throughout the flask is uniform. Because as long as there is concentration gradient, there will be diffusion. Okay. Okay. So all of these, if you
And
write all of
there is an elastic collision between the particles.
yeah, you can also say that they are colliding with each other against the wall of the container. Okay, and they're exerting pressure against the wall of the container by colliding against them. Yeah, those all are kinetic theory, and you can mention all of them. Okay, then you will gain all the 3 marks, inshallah. Okay, question part D. Bromine forms a variety of compounds with other halogens. What are halogens? What are halogens?
I'm group number 7.
Very good. Bromine reacts with fluorine to form bromine 1 fluoride. This is the formula. Write an equation for this reaction. This is easy. Who can do this? Bromine reacts with fluorine to form bromine 1 fluoride. Write an equation for this reaction. This is so easy. Yes, Sabiha?
They do not understand what they're trying to ask.
I cannot hear you. You speak so soft.
Teacher, I cannot understand what they're trying to ask.
Teacher, can I tell?
Yes, please. Yes, Rafi.
Teacher, Br2 plus Cl2 makes BrCl, 2BrCl.
Br2, then what? Plus
Cl2.
Cl2?
Teacher, chlorine is diatomic.
Fl, you mean? F?
It's between fluorine and bromine.
Yes.
I thought you said chlorine.
No, beta. No. With fluorine. F.
Teacher, F is also 2.
Yes,
I
very
guess,
good.
because it's diatomic. So
All
it will
the
be
halogens.
BrF3.
But beta, okay. Also, please pay attention to the question. They've already told you the product. Your product should be this. Okay, bromine 1 fluoride. This. Okay, you cannot have any other product. They have told you to make an equation with this as the product. Bromine 1 fluoride, BRF. Now, is this balanced? Okay, okay. Halogens always exist as diatomic molecules. Always. Sorry. Yes. Always they exist as diatomic molecules. So this is one molecule of bromine. This is one molecule of fluorine. Okay. Now they give you. Let's make this. And this. So this is one bromine and this is fluorine. Okay. So is this balanced? How will we balance it? Yes, Javeria?
We will add a 2 in front of bromine fluoride.
Yes. So this is done. So you're done. Okay. This is what the question is asking. Another compound of bromine and fluorine is bromine 5-fluoride. Calculate the percentage of bromine by mass in bromine effluent. Now this you don't have to do at this stage. Okay, so I think we are done. We are out of time now. Is there any question, or if you guys have any past paper questions that you have been trying and you have any confusion with or any problem with, please you feel free to let me know and send me those questions privately or in the group, whatever, but before the class, so that I can go through it and then I can discuss in the class, or even in the class you can give me a question. Okay. Okay, then tomorrow I will discuss speed, velocity, and acceleration graphs. Okay, that chapter. I will discuss that chapter for grade 8. I mean, other grades are also welcome by me, but that chapter I think is included for grade 8 exam. Okay? Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.